In this video, I'll show you how to move your StorJ storage node from a bloated Windows system running the exe installer to a simple Linux system running in Docker. While I'm preparing the environment here in the background that I'll be working on, I suggest you get a cup of coffee, and if you don't have a storage node that you're moving, this video is not for you. If you're like me, you probably started your StorJ journey on Windows because that's what you knew. Now that you know more about Linux, you want to move it there to save on resources, and in this video I'll tell you how to do it in what I consider the easiest way. Do note this method may not be the fastest way out there. I'm very sure actually that it ain't, but in my opinion it's the easiest. In the background I'm installing Debian. I've sped up the video a ton, but if you're interested in the commands, I've put my install script in the video description. To also note that this video is longer than it absolutely have to be. I've put everything as verbose as I can, and I'm taking my time to show you exactly how I do it, because when I was starting out with Linux, and truthfully still so, I want things to be explained as well as possible. Alrighty-o, I think we're ready to get to it. I'm running btop here. It's a terminal stats program that I'll be getting back to within the video. In the other tab I have the Windows computer open here, and then let's run PowerShell as an administrator to begin our removing process. The first step is to stop the service of the storage node. I'll then also stop the Storagenode-Updater so it won't suddenly get restarted by the updating process. If you type get-service and then say storage node afterwards, you'll see that the status of the storage node is now stopped. That's perfect. You can see that I have my storage and my databases on two different drives. And for my approach, I want to move the database files first. So let's open up one window on the right hand side of the screen, another window on the left hand side of the screen. On the right hand, the destination, I'm going to try to navigate to the newly instantiated SMB share that we just made on the machine before. If you're interested in how we made that, then once again, go to the video description where I put the script for the installation. I'm logging in with the Docker user that I created, once again in the script below, and then I'm navigating to the storage folder that I created. I always like to create a test document just to make sure that I can actually write something and that I have privileges to do so. If we go back to the Debian system here and go into the mount drive where everything is mounted, we can see the contents of the file that we just created. The file is there, and there's the contents of it. Very smart, nothing is corrupted, all is there. Let's open up btop again and go back to the Windows system. We obviously don't need the dummy file, so let's go ahead and delete that. We can just navigate to the database, create a folder on the destination called database, and then just Command X and Command cut everything into there. It should be pretty speedy, both because the files are larger and because there are not many of them. Going back to btop, we can see that the download activity is immediately spiking along with the CPU activity, who is accepting all the new pieces. Going back to the Windows system, everything is done, and that's it for databases. Now let's tackle the storage folders themselves. Garbage, Ctrl-X, Ctrl-V, Bastor, Ctrl-X, Ctrl-V, Temp, Ctrl-X, Ctrl-V. This is all working fine, because the files are so small. Keep a mental note of that StorJ verification file, by the way, we'll need that later. The blobs and trash files are both very, very large. I'm trying to open up the properties here, but this will just continue on forever. These are great. So we need a more efficient way of moving these. I'm going to create a new folder over here called storage, and then I'm opening up PowerShell. Now in PowerShell we're invoking a Windows proprietary program called Robocopy. Once again, don't worry, I do have the script that we're going to be running from PowerShell in Robocopy in the video description, so you don't have to type anything yourself. But it's pretty simple. We have a source directory, we have a destination directory, and a variable for how many threads that we're going to be running. The destination can just be had by going to the destination window, typing Ctrl-L to copy the URI of that destination and putting it in the variable. I'm then manually typing the storage directory, which we have to be very specific to target. For threads, I'm upping the thread count a bit to 12, and here's the entire command that we're going to be running. I'm doing np for no process as well, but this is updated in the video description, don't worry. I'm then marking these 3 lines and pressing F8 on my keyboard to put them into memory. I'm then putting some comments for you, you'll see that later. There we go. And then the Robocopy can be started by marking it and once again pressing F8. You'll now see that everything is started. The Performance tab in the Task Manager should show that your memory is rapidly increasing. I found that this is only true for the start of the moving process. I think this is because Windows is getting a tally of the entirety of the files to move, and then after some time everything will settle down to normal usage. Here we're seeing a graph view of the rapidly increasing memory usage. Once again, don't worry. And if we try really quickly to go to the Process tab, we can also see that the memory of PowerShell is increasing. This is expected, don't worry. Back in the Debian tab, we're not seeing a whole lot of activity right now, because Windows has not started the copy process yet. The memory is just about maxing out right now, but it shouldn't be a problem. If you run out of memory, it'll just take a bit longer. Windows is smart enough to not crash. At least we hope. I'm going to be putting the PowerShell on the right-hand side and the Memory tab here on the left-hand side. Going into Debian, we now see that the transfer of files has started, marked by, once again, the Download tab showing 2-point-something megabits. Oh, it's jumping up there. And once again, the CPU activity is showing activity as well. Everything is as expected. Don't really need those tabs right now. And I just really want to show you that drive activity is in fact happening. So I'm going into the Synology drive station here that's hosting both of the virtual machines that you're seeing. We are logging in here. I'll then open the resource monitor and go to the disk tab, where the custom view will show us individual drive performance, and it's pretty obvious that it's drive 3 that's getting copied from, and drive 11 that's being copied to. Back at the BTOP instance in Docker, we can see that CPU and download activity is both going forward as we expect. And back in Windows, we're seeing Ethernet and drive activity, very cool. And after 25-ish minutes of in-game time, we see that the memory usage also has fallen. Just because memory usage has fallen though does not mean that the file transfer is finished. Far from, actually. Going back to BTOP here, we see that everything is continuing as normal. But no one really wants to watch a file transfer happen in real time with these lengths, so let's go ahead and skip until it's done. Alright, we transferred 4 terabytes and it took an entirety of 2 days before that's happened. It's a lot of time. We now see that the activity in the Debian BTOP instance has stopped, and if we navigate to the folders on the drive on the Linux machine, we see that all the files are there. Exciting. Alright, let's start to create the data structure for the Docker container. I'm making the data an identity. Oh, and I moved the identity folder from Windows. I forgot to tell you that as well. Looking in the identity, we see that all of the files are here, so I'm moving it into the newly created identity folder and then creating the remnant from the Windows machine. I'm then also moving the database folder into the new data folder, the garbage folder, the hash store, the storage folder, and the temp folder all into data. In the folder of the Docker, there should now only be 2 files after we remove the storage door verification as well. So I'm going to create 2 files, the setups.command and the docker compose file. The setup.commands file is where I'll put the initial creation for the Docker container. We don't necessarily need that, but it's a good thing to have. And the docker compose file is, well, it's a docker compose. The structure and hierarchy that you just saw flash here in the background I've also put in the video description, so don't worry about that. But in the root of the data folder there needs to be a bin, there needs to be a orders, there also needs to be a retain folder, a storage folder that we already have, and within the storage folder we need to have all of the database files. Let's check if we have that. We do, very nice. And if we check in the database, well, indeed all of the databases are there. So let's go ahead and move them to storage folder. And then once again, we'll remove the remnants of the database folder. The identities need to be there, but we've already checked that. And the structure of the root data folder is now looking like it should be. Now you're seeing me here being a bit confused why I have a garbage folder, because I don't remember it being anywhere in Docker. I think this is just a Windows thing, so I'm moving it to storage and forgetting about it. I guess I could delete it, but you know, now it's there. I'm also moving the temp directory into storage as well. I think at this point we're all ready. Regarding the hash store that's still here, that's for future development. It's empty right now, and just go ahead and move it to the storage as well. I'll have this updated in the file in the video description. There we go, cute data folder. I've gone up a level back to the root of the storage node folder, where I'm going to be editing the Docker Compose file. This is much easier to do through a real SSH session instead of doing it on the virtual KVM of the virtual machine. So we're just logging in here, good stuff. And once we've logged in, we need to change directory to the, once again, root folder of the Docker that we're going to be creating. And then I'm putting in the contents here of the Docker Compose file. Let's go ahead and save that. And if we've done everything right, we should be ready to up the Docker container. Since we haven't run any containers on this system before, the Docker image has to be downloaded, which it just does automatically. At this point, the storage node should start running all by itself, but as you can see, I'm getting quite a lot of errors. You don't need to worry about this, you just need to fix the errors. So let's go ahead and do just that. I'm stopping the node manually and scrolling up a bit here. You see that some of the error settings that we're getting here is invalid configuration, operator wallet address is not valid. And that is true, I never said it when I copied in the Docker Compose file. I changed that off camera, and then let's go ahead and try to do Docker Compose up once again. We're getting errors again, which is not great, and as you can see the storage node is restarting. So I'm stopping it manually, and once again let's check the errors. There are quite a lot of them. FileWalker is complaining. And I'm just trying to scroll here to see if I can find anything, a pattern, something useful maybe. But the first error we get here is an unexpected shutdown of a runner because the verification and readability of the storage directory is not great. If this happens to you, as it does to me, this is because that storage verification file is corrupt or missing. I corrupted mine on purpose so that you can see how to recreate it. Taking a look at what's in the file, it's supposed to be a binary file, but I just overwrote mine with a bunch of nonsense characters. So let's remove the storage verification and let's go to the other file in the root of your storage node to check out that one. This one is the setup.commands file, and we haven't written it yet. So once again, let's open up Vim, and then I'm just gonna copy in the contents. Once again, find this in the video description. Everything here should be fairly simple. It's just a Docker run with the setup flag set to true. I guess you could build this into the Docker Compose file, but I haven't. We're removing the old container here, just to make sure that there are no duplicate containers. I'm stopping it first and then I'm removing it. And after that has been done, we can run the setup commands. Here it's complaining that the trash uses day-dirt indicator file already exists. So let's go ahead and remove that so that the setup process can successfully run. Don't worry, the setup process won't delete any of your existing data. I've removed the file. And now the storage configuration already exists. So let's go ahead and remove yet another file, data and config YAML file. And then let's try to run this setup once again. As you can see, we had no errors this time, so everything is fine. I'm gonna hop into Midnight Commander real quick, go into the Datas directory, into the storage directory, and here we should be able to see the new file that was created in the setup process. There we have it, StorJ verification. Let's go out of MC here, and then let's navigate to the file, and we can check what's inside it. Yeah, it's a binary file, so there's nothing human readable in there, but this is how it's supposed to look, at least something like that. We're now ready once again to do the Docker compose up and check if we can get anything on the storage node itself. We're getting all infos and successes, and I took out everything that's not above warning, so we should be getting only errors. These blobs cache errors are perfectly fine. This is just part of the process, and that we're getting some of them continuously is also just fine. Navigating to the dashboard of the storage node, we see that it's now indeed up. I'm on the Debian 14 machine, as you can see in my URL. None of the statistics are reporting as they should be. Just give the node a few hours and it should be there. I did just that, and after refreshing the site again, we can scroll down and see that we now have 3.68 terabyte used, and we have the average disk space used this month of 4.64 terabyte. We're now ready to decommission the old Windows machine. This is a virtual machine, so I'm just gonna power off and delete its virtual hard disks, but if it was a physical machine, yay, now you have a machine to do something else with. Congratulations. We can go back into btop here and see that the actual resources needed to run the node are very low. Hey, thanks for watching my video. If you like this one about storage, you might also like this one about storage, where I built a new storage node. Very cool. You might also like this one, at least that's what YouTube tells me that you're supposed to do. Otherwise, cheerio, have a good day.